From manual memoization to automation. How React compiler replaces useMemo, useCallback, and React.memo. 1. Introduction. Let's begin with the core idea. In React, whenever a component updates its state or receives new props, React re-renders that component. By default, this also triggers the re-rendering of all its child components, even if the data hasn't actually changed. For small apps, that's fine, but as your application grows, these unnecessary re-renders can make your interface feel slower and less efficient. That's why React gives us tools to control and reduce re-rendering when it's not needed. These tools are called React.memo, useMemo, and useCallback. 2. Understanding the problem. Imagine you have a parent component that updates every time a user clicks a button. Inside it, there's a child component that displays information about a user, for example, their name. Each time the parent re-renders, the child re-renders too, even though the user's name hasn't changed. This happens because React treats the child's props as new on every render, even if they contain the same values. Now imagine that your app has dozens of such child components. Each one re-renders unnecessarily whenever the parent updates. That's where performance can start to suffer, and that's where memoization tools come in. 3. React.memo. React.memo is the first tool we use to solve this. It tells React to skip re-rendering a component if its props haven't changed. So, if the child component always receives the same data as before, React.memo ensures it won't re-render. It essentially adds a memory layer, allowing React to compare the current props with the previous ones and decide whether the component needs to update. However, there's a subtle detail. Even if the data looks the same, React might still treat it as different if the parent creates a new version of that data every time it renders. This happens often with objects or arrays in JavaScript. 4. useMemo. That's where useMemo comes in. useMemo helps React remember the result of a calculation or a value between renders. Instead of recreating the same object or value every time, React keeps it stored, or memoized, as long as its dependencies haven't changed. By using useMemo, we ensure that the data passed to a child component remains stable across re-renders. This stability allows React.memo to recognize that the props are truly the same and therefore skip unnecessary updates. In simple terms, useMemo helps React remember computed values so they don't trigger more work than needed. 5. useCallback. Now let's talk about functions. In React, every time a component re-renders, all the functions defined inside it are recreated as new functions. Even if they do the exact same thing, React treats them as brand new. If you pass one of those functions down to a child component, React will think the child's props have changed, causing it to re-render unnecessarily. useCallback solves that problem. It works like useMemo, but specifically for functions. It tells React to reuse the same function between renders unless one of its dependencies actually changes. This keeps function references stable and prevents avoidable re-renders in child components that depend on them. 6. Putting it all together. When we combine these three tools, they form a powerful optimization pattern. React.memo prevents child components from re-rendering unless their props truly change. useMemo keeps values stable between renders, so React.memo can detect that nothing changed. useCallback keeps functions stable between renders, ensuring React doesn't treat them as new props every time. Together, they make React applications faster and more efficient by minimizing the amount of work React has to do during each update. The parent component can re-render freely when its own state changes, but the child components only re-render when their actual data or behavior changes. That's the essence of React's performance optimization strategy. 7. Summary. React Memo stops unnecessary re-renders by comparing old and new props. useMemo remembers expensive calculations or values between renders. useCallback remembers function references to prevent them from being recreated. All three work together to make React smarter about when to re-render components. 8. React compiler. And finally, it's worth noting that the React compiler will automate most of this logic. React compiler's main purpose is to automatically optimize your React application at build time. That means you'll be able to write clean, simple components while React takes care of memoization behind the scenes, giving you both readability and high performance without extra effort. Here's why with the React compiler it works now without useMemo, useCallback, or React.memo. 1. Automatic memoization. The React compiler analyzes your code at build time and automatically memoizes components and values where needed. You no longer need to manually wrap objects or functions with useMemo or useCallback. 2. No manual optimization needed. The compiler automatically ensures that the child component will not re-render unnecessarily when count changes, even though user is defined inline in the parent. 3. Cleaner code. You write just the logical structure of your components, the compiler handles re-render optimization internally.